Assalamualaikum, my name is Nurabata Odia Bintara Nizam. Matrix number is 229480 and I will be presenting about introduction. Design of experiment, which is DOE, is a statistical method used to plan, conduct, analyze and interpret experiments. It enables multiple input factors to be studied simultaneously that will allow researchers to identify significant factors and interaction that may be overlooked using the one factor at a time approach. In this experiment, DOE is applied to optimize the performance of a water rocket, which uses pressurized air and water to generate thrust based on Newton's third law of motion. DOE approach provides a systematic and data-driven method to determine now desired variable, effect flight stability, and maximum altitude that will lead to the identification of the most rocket configuration. The objective of the experiment is to measure maximum altitude reached across a range of water volume. Secondly, is to establish a clear quantitative relationship between water volume and air pressure in order to get the highest altitude achieved during the trajectory.
Okay, next, I will continue the presentation of response variable. First, I will introduce myself. I'm Akila Mitamayani. My matrix number is 230249. And for response variable, we have three. First, quantity to be measured is horizontal flight distance, unit measurement meters, and type of measurement a standard 50-meter measuring tape. Next, we will go to the next page. Okay, the next one is factors and levels. We have two factors, factors A and factor B. Factor is the volume water. The high level is 1600 millimeter and the low level is 3000 millimeter. For factor B, there is launch pressure. The high level is 50 and the low level is 30. Factor A is a water volume. Volume 3000 milliliter, that is the low, provide insufficient mass, causing the thrust phase to end prematurely before the stored phasor energy is fully utilized. Meanwhile, high volume 1600 millimeter is heavily increased the initial dead weight of the vehicle, which increases the gravity workload during lift-off and limits the peak acceleration. For factors B, there is launch pressure. A higher internal air pressure establishes a greater pressure differential between the inside of the bottle and the outside atmosphere. This increased differential pressure forces the water propellant out of the nozzle at a much higher exhaust velocity. Higher exhaust velocity translates directly into a larger initial thrust force, allowing the rocket to achieve higher upward acceleration and a significantly higher velocity at the end of the thrust phase, which maximizes its vertical displacement. Then I will pass to the next member.
For this experiment, we use full 2 power of 2 factorial design to analyze the factors that we have, which is water volume and air pressure. So 2 power of 2 is equal to 4. So we need to run four tests for this experiment. So for the first test, we use higher water volume than air pressure, and we get our maximum altitude is 15.7. So for the second test, we use lower water volume than air pressure, and we get slightly lower maximum altitude from the first test, which is 8.2. So for the third test, we use both water volume and air pressure high. So the result that we get is also higher, more than all the previous tests, which is 30.4 meter. So for the last test, we use both lower water volume and air pressure, and we also got the lowest maximum altitude, which is 4.3. So for the experiment, randomization was applied to reduce systematic errors and environmental variation that will ensure the factors such as wind and operator fatigue did not bias the results, and each data point remains statistically independent.
Hello everyone, my name is Ashri Shashari Sulaiman. My matrix number is 230083. So I will continue with the result for this experiment. The first one is we got the table and the graph for the entire experiment. Both of these products can be affected by water volume and the launch pressure. As you can see the table, we can see we have four run for experiment. We have the water volume, we have the launch pressure, and we also have the maximum altitude in meter. The graph also we plotted by information by the table. We have the low and high for the psi and the milliliter for the water volume and the launch pressure. You might ask, what is this affecting for? For this one, the water volume it affect by the low and high water volume. You can see we have done the calculation. 23.05 meter minus by 6.25 meter, we get the 16.8 meter. The 16.8 meter is the result that indicates for the increasing of water volume from 30 milliliter to 600 milliliter for the increase. The increasing is the 16.8 meter. It is approximate for the max of the volume to make the significant factor for the rocket performance. The next one is for the launch pressure. The launch pressure, the same. We create the high and low pressure, and we subtract it 19.3 meter minus 10 meter. We get the 9.3 meter. There is the increase of launch pressure from 30 psi to 50 psi. That is improved the average altitude by approximately 9.3 meter. It shows the launch pressure also have a positive influence on the rocket performance. The next one we continue with the discussion. Um, for the both result, it suggests a positive interaction between the water volume and the launch pressure. It benefits the increasing pressure becomes more significant when a larger water volume is used. From the result, we can see that both factors positively affected the altitude of the water rocket. However, the magnitude of the water volume, which is the 16.8 meter, that is the greater than the launch pressure, which is 9.3 meter. It indicates the water volume had the strongest effect on rocket altitude within the tested range. That's all for me. Thank you so much for listening.
Lastly, the end of presentation with conclusion. Based on to find to full factory design, the primary objective of quantifying how operational parameters dictate the water rocket apogee was successfully achieved. Factor A, water volume, was the most dominant variable, yielding a main effect of 60.8 meter due to the critical role of reaction mass in sustaining kinetic propulsion, which factor B, launch pressure, produced a significant main effect of 9.3 meter by increasing initial thrust force. A strong positive interaction proved that pneumatic pressure gains dramatically when paired with higher propellant volume, demonstrating that the optimal system configuration of high water volume 60 millimeter and high launch pressure 50 psi mathematically optimize the propulsion system to achieve a maximum peak altitude of 30.4 meter. That's all from Group 19. Thank you.